Take one.
Hello, today we're going to go over what will be the third experiment in our A&P labs. You will encounter this likely in the second week of our spring semester, and this is our ECG PowerLab experiment. So we're going to again view something that will be a interpretation of our heart rate. Specifically, we're looking at the electrical events of the heart this week. And the setup is going to be a little bit more complicated than your introductory lab that we went over in the fall, more on the level of the EMG, your second experiment. So what I'm going to do is open up this PowerLab box, and inside here I'm going to grab out from the bottom the things that I always need: the USB cable, the power cable, and then finally the AD Instruments PowerLab box. So this is what I'll need in every experiment that we do. Then for today we need some other specific things. And from the bottom portion here, we are going to grab what's called a shielded bioamp cable. So this is this cable right here. So it's shielded, and the shielding basically reduces the electromagnetic fields in this cable. That's going to also enable us to connect different leads on different channels. So here it actually labels the channel 1, and there's a positive and negative, and then there's channel 2, and there's a positive and negative. There's also a earth. So this is our grounding lead right there. Now, what I'll grab from the top are some wires that are fortunately color coordinated, and all these wires are nicely coiled. This is the way we want to put everything away. This is going to be great for the next time you use the PowerLab system, or some of your peers come into the next lab and use this. So let's make sure that we coil the things up nicely. And after I've grabbed that, I'm going to grab out these clamps. Now, the clamps enable us to, through a very non-invasive type of setup, enable us to look at the ECG. So once I've grabbed that, I'm pretty much set up to go. So I'm going to just take this box out of the way. I close it up, make sure nothing's sticking out of it, and move it out of my way. So now I have everything that I need to set things up. And what I'll do are the basic things, the things that you should already know how to do first. So first I'm grabbing the PowerLab power cable, plugging it into the back of the device here. It's going to go right into there. And right next to that is our power switch. So I will plug that in. Over to the other side is the USB hookup. There's a little USB icon both on the box and on the cable. So I'm going to plug that in. And those are the basics to get this to work every time. Now over on this side of the table we actually have a power strip. So I'm just going to plug that in over here. And now I'm powering my box. Right now there are lights on. I'm just going to turn that off briefly till I get everything hooked up. And I'm going to hook the USB cable up to the front of my computer here. And now we're set up so the box is powered. I'm just going to click this switch on, and what you'll notice is that there will be lights turning on right over there. Now, we are going to hook this up to what's called the bioamp input right over here. And from there, we're just going to hook up these cables, which are nicely color-coded. So for today, what we're going to do is simulate a lead 2. A lead 2 works off of a setting of 3 electrodes on the body, 1 positive, 1 negative, and 1 ground. We have covered this information in our pre-lab content for the week, so that's going to cover the physiology side of the ECG. Okay, so we're going to use a channel 1 for this, and what I'm going to do is I'm going to use the black and the white. Now my clamps are not going to correspond to these colors. The other ends of the leads will, so just bear with me and as I talk through what I'm connecting, it'll make some sense here. So I'm going to hook up the white to the negative and the black to the positive. For lead 2, our negative, our white, is going to go to the right arm, while the black, the positive, is going to go to the left leg. So we'll just remember that as we go through this setup. Then the earth is going to go to our right leg. So I'm going to start with that, get the earth out of the way, and what I'll do is connect this clamp. It clips on there very simply. What we'll do is we'll also use some conductivity gel. So this has some salt in it, and the salt is going to improve the conduction system, or it's going to improve the conduction across from your body to this clamp. So if I put a little bit on here, just going to take a little bit off of there and put it on this area right down here. And then what I'll do is I'm going to clip this onto my right leg. So I'm going to go down here and I'm going up on my ankle, above my sock, and once I'm connected there, I have everything I need for the ground set up. Now I'm also going to do the same thing with my positive and negative. Now remember that the negative is white, so the negative wire is over here. And with this negative wire, I'm going to use the red clip just because we only have a red clip and a black clip. And I'm going to clip this same way just on my right arm. And then I will clip the black, the positive, and this is going to again get some conductivity gel and be connected to my left leg. So now I've set everything up, and this will be enough for me to get a measurement of, well, what I'm actually getting is I'm getting the influence on the current running from my right arm to my left leg due to the conduction system of the heart. So I will just come over here, and what I'm going to do is go to my little Windows icon. I'm going to click this button here, and I'm going to type in ECG Settings. Bear with me a second here because my right arm is not functional right now. And I'm going to type in ECG Settings, and there I go. I have my ECG settings. I check that my PowerLab box is on. That way I know the software will start up and be connected to the box. I may get something about legacy inputs being not supported. We can just click OK there. And we are happy because we have a little green button right there. So now what I'm going to do is I'm going to click on this green button. And everything is working pretty well. We do have what looks like an ECG to me. There's a number of things that I can do to clean this up. First, I'm going to slow down the time scale just a little bit here. And now I'm going to go into my settings area. In this case, we're using the bioamp hookup here. So in this bioamp area, I can make some changes that are going to be helpful to make this a cleaner signal. I am going to just change the sensitivity a little bit so we get a little bit of a bigger spike in the R wave and every other wave that we're looking at. So that looks pretty good. It's taking up most of the screen. I will just go over here to this negative icon or minus icon and go click. And actually I can work with the bigger one. So let's go with that bigger one here. If we do notice that we're getting towards the top of the screen, we can turn down the range in here. So again, it takes a little tuning to get this to work perfectly for us. So I'm just going to drop this to 2 millivolts and see if that's something we can do. So right there, good enough for me right now. I am going to now put a filter on this. So here we have a low pass filter. I am going to just see how it looks if I put a 10 Hertz filter on there. Okay, we have a great clean signal. It's actually reduced some of the amplitude of the signal. So let's go and just make this a little bit larger. Nice quick adjustment over here with the positive icon. Again, that's getting a little bit too big, so we'll work with this. We can always magnify it after the fact. But what I'm looking at here is the conduction cycle of the heart, and I'm just going to let it go for a second, nice and quiet. Okay, so now I can stop this, and I'm going to disconnect my subject. What I'll do is, that electrode gel of course has salt in it. Salt can be corrosive, so we're going to clean this off with a little alcohol swab. That way we won't have any type of corrosion on these. So we'll clean that off after the fact. Before I talk about the signal, this worked out okay for us with the clamps today. We did turn out with a really nice clean ECG. That's not going to be true with every subject though. So you always have the option in lab of using electrodes. And these are nice 3 packs of electrodes. For this setup, we're going to simulate the same thing we did, but we're actually closer on the heart. So we're going to get onto the torso. If you're comfortable with this, we're basically just placing one lead here, the negative, we're placing the positive here, and then we'll place the ground over here. So we're doing this all on the torso. You can see that that'll relieve a lot of the noise because we're not going so far out on the limbs. And I've actually pulled up a little diagram here that's going to show us the same setup. So what we're doing is we're running a current from the right arm to the left leg, not actually on those areas, on the torso, and that's simulating what we would call a lead 2. So it's the most common lead. We do that because that's the common axis that the heart depolarizes on, and this is really used to identify normal sinus rhythm for when we're looking at patients. So when I say normal sinus rhythm, that's just originating at the sinoatrial node. I'm not going to go into that because we have that in your pre-lab content. Now I want to show you a new tactic that you probably haven't seen before, and this is just how we're going to magnify part of the screen. So I'm going to find the portion that's cleanest for me and I'm interested in, and I'm going to click over here and then go across. Now, once I've clicked that, I've selected that area, I can go to this window area up here, and I want to click the little magnifying glass. That indicates that we'll go to a zoom view. And now we have a really pretty clean ECG, especially considering that we use the clamps for this. But what we can pick out here is we can pick out the P wave, we can pick out the QRS complex, and then finally the T wave over here. Now, you may see a little bit of a wavy baseline in between, so the best way to really identify what is involved in the actual ECG, the conduction cycle of the heart, is to look at subsequent waves. So when I look at a couple different ones, I can clearly see this looks like the last P wave, this looks like the last QRS complex, and this looks like the last T wave. So that's going to enable us to identify and then do some types of measurements on these things. And you know, the last time we went over the measurement of average heart rate, for today we're actually going to introduce some new measurements. So for instance, we might ask you something like, what is the duration of the P wave? So I'll drop the marker at the baseline before, and again the marker is found down in this corner of the screen. So I click there and there it is again. And I'm going to drop that in the area right before I can see that waveform started. We're looking for really a point of inflection in the wave so that we can tell where the beginning and where the end is. And then here, we're going to go towards the end of the P wave. Sometimes it's hard to tell, but remember we're looking at a very blown up area here, so your measurements are going to be, even if you're a little bit off here, your measurements are going to be close enough in seconds that you'll get that right on a test or quiz. So I'm going to move over to the end right here, and that again is going to give me a change in time. Here I get 1.34 seconds. These measurements are actually used to find norms for the different waves. For everyone, they should be a certain amount of time. So we can tell what's going on with the heart sometimes if we see some disturbance in that. And then we might also want to look at something like the amplitude of the R wave. Now, we just looked at the duration, so there it's important to find the beginning and the end of the wave. Here what we're trying to find is the baseline for our initial and the top of the peak for our final measurement. So I'm going to this baseline before here. I don't have too much of a wandering baseline. And so once I've found this starting point, I move up to the top here and get right on the top. And there what I'm looking at is it says ECG equals, and then it gives me a delta, so a little triangle, and it gives me delta 0.510 millivolts. So that is a measure of change in voltage right there. And again, this is turning what we get from an electrical signal or current running through the body to an actual deflection in voltage that we see on the screen here. So we can also calculate things like average heart rate with this as well. We do that as the same as we did in our introductory PowerLab where we use the pulse transducer. So that's the setup for today. At the end, like I mentioned, make sure you clean off any electrode, the conductivity gel on here, and take these apart, and once they're cleaned off, once everything is coiled up, put it back in the box nice and clean so it's ready for the next person. Thank you very much. Have a good time in lab this week.